you're not share your screen.
Yeah.
Okay, so who traveled the farthest for the eclipse? And I know where you went.
I traveled to the parking lot.
Huh? I had a friend driving to St. Louis, or flying to St. Louis, and then driving to Kentucky to see it. Anybody tried driving down 95 on Sunday?
We're gonna switch you right away.
We went out the big, the big party was going on. And it was happening. I think so. Eventually we just got back and we had a better view from.
Oh, way better.
Yeah.
Right.
You have a full hour now, or
We can start now.
okay, all right.
It depends on how many questions people ask and stuff. So
Okay.
I didn't really time out how long it's going to take.
Okay. I want to right after start off. Use it back.
That's
Right.
fine. I can just wait.
Thanks everybody for coming out. We have, I think, less than the usual attendance because we didn't put an announcement in Dateline, so I don't think everyone knew that we're actually going to have it. Which brings a point again of the little red hen. When the little red hen goes on vacation, other little hens need to take over. That's why we posted in the Slack channel for the all the instructions for how to set everything up. Everything is laid out there. There's sticky notes for where the plates are. Put them on my desk. Any questions? I'm pretty sure is like 30 or 40 engineers that come to this meeting. We'll figure it out. I'm just adding the instructions and then we'll put it in the instructions for later. The live stream information is in there as well. Where actually the recordings have been going somewhat okay lately. I think this one will probably be smooth the whole way through. I'm hoping. I can see Bradley's screen. I can see his mic is on. My mic is off, so they can't hear this, but they may hear a little bit. But the recording should go well. So that'll be out with the show. Not show notes. It's not a podcast. With the meeting notes afterwards. I misspoke last time when I thought we didn't have a speaker for today. Bradley is our speaker today, but we do not have a speaker for the next one.
Just do it again.
We're going to start going into reruns real soon if you guys which we may actually do the kids series not too far in the distant future because our company is picking up KIT hopefully as the standard. And so there's going to be a lot of people that need to relearn it. And it'd just be good to kind of go over it again, I think, as well.
What are you using right now?
My team is using KIT. But we're trying to do it across the, like there's some other people using Subversion. There's other people using their file system as source control.
Okay, is anybody using CDS? I'm curious.
Yes, I believe there are some people that are using CDS. So I think they might even be a source safe use in there as well. Yeah.
I didn't know that existed.
Yeah. Looking at some, I went on vacation and I was oddly, when we got to the resort, they told us that you can only have 2 devices on the internet. Oh. My wife and my daughter looked at me like, I guess you're short. So I was looking at really old stuff. They had my computer hadn't updated anything that actually was looking at some old commits from source safe, so it was interesting. But I won't bore you guys with that. Bradley's going to be talking about the QT framework today. Again, if you have anything to speak about later, please let me know. Send a message in Slack or email, whatever, however you want to do it. With that, let Bradley take it away. Is there any? Oh, yeah, I'll do that while you're talking.
Okay. So today I will be talking about the QT framework, which is a C++ cross-platform framework. So just to give you a little background about my experience. So when I first started at NASA, I actually had no experience with C++ or Qt, and so I've been working with it for about, I would say about 3 years now. And so I'm definitely not an expert, but I do have a good amount of experience with it now. So first, what is Qt and why would you ever want to use it? Those are the two big questions. So as I said, it's a cross-platform framework. And so basically what that means is that it compiles on a number of different OSs. They cover almost all the major OSs. So that includes things like a majority of all the Linux distributions, Mac OS, Windows, and they also do compile for Linux, embedded Linux, and then also for different mobile architectures. It can be used in both GUI and non-GUI ways, and so they provide a whole framework with all kinds of widgets and all different classes to do GUI type work, but then there's tons of different non-GUI ways you can use it also. So the question of who uses Qt, so there's actually a ton of big companies that are using it right now, and I'm sure more and more are starting to use it. LG Smart TV, they use it for their web OS applications. So anytime you buy an LG TV now, it's going to be running Qt on it. Ubuntu OS is actually starting to use Qt a lot more, and they use it for a bunch of different interface type stuff. Wireshark recently just ported their code base over to Qt, I think. I think before they were using the GTK framework, but they decided that that wasn't flexible enough and it was harder to support for multiple different OSs, and it didn't provide as nice of a native look. And so they switched their code base over. Bitcoin Core, which is the Bitcoin Foundation's implementation of the of how you can access and interface with the Bitcoin blockchain network. VLC, which I'm sure almost all of us probably use, which is the huge video streaming or video playing application. They use Qt. KDE framework, which is used for tons of different OS UIs and all kinds of different UIs. They also are built on top of Qt. So also, just so I can say this, so the correct way, the way they tell you to pronounce Qt is actually supposed to be cute, but I really dislike that pronunciation, so I always just call it Qt anyways. I refuse to call something I use cute. So why else would you want to use it? So they provide both proprietary and open source licenses. So that means that you can actually purchase the product from Qt, and they provide robust support and all kinds of teaching, and they basically help you out whenever you need it. Or you can use the open source licenses for your projects. The different kinds of open source licenses they provide are the GPL 2 and 3 and LGPL 3. Qt is also modular and fast. So what I mean by modular is that they've broken up their whole framework into different modules. And so depending on what you need for your type of application, you only need to include that. And so it keeps your code base and your final binary application size minimal. For instance, they have the Qt core module, which is what contains all of their custom containers, like string manipulation. And so if you want to write non-GUI applications, a lot of times you can only use the core module, and you can completely forget about all the GUI components. If you want to use GUI type programming, then you would need to include the GUI module. And then they also have tons of other separate modules for network type programming. They have a whole module for OpenGL. They have a test module, all kinds of different modules. One of the nicest benefits of Qt, I think, is that it has really, really nice documentation. So almost everything in Qt is well documented, all of the classes. They have tons of examples. They have integrated docs with their IDE, and they also allow you to easily generate documentation for all of your code and to use it within their IDE. And so the kind of documentation format they support is they support the Doxygen style documentation, which supports either Java style or JavaScript style documentation, or there's a JavaScript style also. I just want to show you, so I'm going to be switching between examples and sort of give you a better hands-on view of how some of these things work. So for instance, this is the Qt creator that comes with Qt. You don't have to use it, but I think it's really powerful and it provides a lot of really nice things. So for instance, the built-in documentation all you would have to hit is F1, and it pops up the documentation for that code.
Qt Creator is the ID.
Yes, so Qt Creator is the IDE that comes included. You don't have to use it, but it really integrates nicely with a lot of different Qt functionality. This is one of the nicest ones, I think, because you can be doing your code. You don't have to go to the web browser. You don't have to leave what you're doing. Just hit F1, and it brings up the documentation for whatever you're working on.
What compiler does it use?
So, yeah, so it supports, you can use it with GCC, CLang. So it all compiles down to just pure C++. So for Windows, it uses, I think they support Mini GW, and then they also support Visual Studio C++ or Visual C++. For Linux, they support G++, GCC, which is the same thing, and then for Mac, they support CLang also. So pretty much any of the major compilers it works with. So it also includes a really intuitive API. So they call their API a property style API. So you create your object, and then you basically set a bunch of different properties on it. It makes the code really readable. One of the reasons why they kind of chose to do it like this is because C++ doesn't support some features that newer languages have, like keyword arguments. So you can't just pass it in the constructor and say, you know, this field equals this. Otherwise, if you tried to pass everything in the arguments in C++, you would just have a bunch of arbitrary variables and different things. And so it's hard to really tell exactly how you're initializing that object. So by doing it in this manner, it's really clear what this is doing. I mean, even people who probably aren't familiar with C++ or Qt understand what this is doing already.
Single shot.
Well, so basically you start, in this example, you create a timer, you set the interval in milliseconds, so it goes off every 1,000 milliseconds to 1 second. And then you set a flag, you can set a flag called single shot, and so that causes the timer to only go off once. If you set single shot to false, then it constantly goes off every 1 second.
Okay.
Yeah.
What does it mean for it to go off? It's like, they call that-
So yeah, so I didn't include that code here, but I will talk about that a little bit later on. But basically, Qt also has this functionality called signals and slots. And so any object can emit a signal, and that's essentially just a callback to another function.
So it's event-based.
What's that?
Event-based.
Yes, it is event-based. But the signals and slots isn't necessarily always event-based, but I'll talk about it a little bit later on. So Qt also provides really powerful and user-friendly classes. They have their own implementation of pretty much every kind of class you can think of. So they have all of their own containers, which from some people's perspectives can be seen as a pro and a con. But from my perspective, all of their containers compared to like the C++ standard containers, they're a lot more robust and a lot more easy to use. A really nice thing is that Qt also has implicit sharing. And so you can return, for instance, a QList object with all of the memory used, and it doesn't create a copy. It performs implicit sharing underneath so that it doesn't copy memory until you try to write to that same container. This prevents you from having to do some of those more less intuitive things in C++, like having to pass a reference to a list and then populating the list from the reference instead of just returning the list. It also has really powerful string manipulation. So I just want to show you compared to the C++ string class. So the C++ string class is like really bare bones. It's really minimal, whereas the Q string, which is their own string implementation used throughout the framework, it's really powerful. I mean, it has a huge number of functions. So pretty much anything you ever want to do with strings, it's just automatically built into the class.
Does that add more weight to that?
It does. So of course, all these things add some overhead, but adding function calls to classes in C++ doesn't really add any overhead.
Can you get like some of the base classes out of it if you have to like in the other libraries? You can get the C++.
Yes. So all of these. So for instance, the QString class has a function attached to it called toStandardString, and so that returns a standard string implementation of it. And then there is the counterpart from standard string. So if you have a standard string and you want to create a Q string from it, you just call this function and it returns a Q string. Another nice bonus, which is, so this is one of the main supported language bindings, but Python also provides really nice Qt bindings to it. So you can see here, there's the two examples. So you have the Python on the left and the C++ on the right, and you can see that the code is almost identical. There's, of course, going to be some things that are going to be slightly different just because Python and C++ are identical languages, but for the most part, the way you use the framework is pretty much the same. I've never actually used a Python framework much, but I would imagine that if I needed to write Python code, I could probably write it without even having to look at the documentation. It's really extendable. So the way that Qt wrote a lot of their classes is that they've written it so that all the necessary components that you might want to extend, they've, of course, made them virtual functions. And so what that allows you to do is you can subclass different classes and then re-implement the virtual functions that provide your implementation of different things. Because it's also an event-based system, they also have this thing called event filters. And so you can basically install event filters on different objects. And so you can capture events from different objects and basically do whatever you want with it. So this allows you to sort of modify even existing classes that you shouldn't really be able to touch. You can still kind of hackishly do it. I've kind of touched this on a bit, but they have really powerful strings. Here is a little example to show you how simple it is. So for instance, you can create a string and say you have these line delimited text. In order to split it apart into a list of strings, all you have to do is just call split with the delimiter you want to split on, and it returns the string list. And then iterating through the list is as simple as just like this, and here is just outputting the string. This for each is actually a macro built into the Qt framework also. So this was before the for loop in the new standard, C++ standards was really part of the standard. This is what they implemented. And so this more or less does the same thing. It just iterates through containers and you access the elements in the container. Here on the right side is an example of the regular expressions. It's a fairly simple case, but this is just showing that it matches, you can match against like integer strings and stuff. Pretty much any regular expression functionality you want, they have included. So now to get a little bit more into the nitty-gritty of how Qt actually works and how it achieves a lot of these things. So Qt is an event-driven application. So all Qt applications start with this Q application class. So there's a single Q application class for your whole application. You create that in your main. And then a lot of times, so if you're doing GUI stuff, you create your main window. Inside of your main window is where you basically create all of your sub widgets and everything, the rest of your GUI. But within main, this is really all it usually is. And then on the application, you call exec, and exec executes an event loop. So it's basically just looping. Like for Linux OSs, it just calls select. So it just waits there for any kind of network or file description changes. And so it's really intuitive. Yep.
So the window.
Yep.
Is it a native based off of each OS? Or
yes. So the way Qt works is that they have all of their own abstractions for widgets, windows. Pretty much everything is their own abstraction to their own class. And then so underneath, Qt handles all of the different OS differences. And so from the user perspective, everything is the same, but Qt underneath handles writing and drawing different native looks for the different OSs and also calling the different low-level OS function calls.
So on a Windows, it would look like a normal Windows application, but on a Mac, it would use the Mac theme format.
Yes. Let me actually just give you a demonstration real quick on that. So here's our ground support data analysis software that's built with all Qt. So this is the Mac version of it, and I actually just did this yesterday. I took our exact same code base and I compiled it, and so this is it compiled for Ubuntu. The exact same code base.
Okay, did it work the first time?
Yep. Yep. I didn't have to make any code changes.
No magic flags.
No magic flags. So the another main thing that's included with the whole Qt package when you get it is this application called QMake. So QMake basically handles a lot of the stuff underneath. It's basically, you can think of it as another step in the make process. What it does is it works on these project files. It also works with CMake. Let me show you an example of a project file. For those of you familiar with CMake, it's very similar. Oh, yeah. So this basically just defines your project. So for instance, this line right here, this is defining the different Qt modules that you want to use. This is just some stuff to do some version checks. This will, for instance, tell you what your application will be called. This template defines what kind of application you're using. And then here is also where you just define your source files and your header files. Basically anything that you use in your project, you define here. And what this allows you to do is you have this single file for all different OSs. So you run QMake on this, and this will generate the appropriate build files for all the different OSs.
Is it allowed for templates? Because I saw Forms UI.
Yeah, I'll talk a little bit about that later, but it does allow you to also program the interface using a XML format. What QMake also does is it also executes some other applications in the background, but I'll talk a little bit about that later. Here's just a brief example. So instead of it just being make now it's simply QMake and make. Doesn't add much to your process, and it does a lot for you. So this is one of the things, this is one of the applications that the QMake application also calls. This is, the meta object compiler is how Qt achieves a lot of its fancy things. So the signals and slots functionality, which I'll talk about later, it does achieves that through the meta object compiler. It also allows introspection, which is something that C++ by itself does not support, which is a really powerful functionality. Qt also has a whole properties framework that it supports, and this also allows you to do asynchronous function calls really easily. These are just some of the different, so the way the meta object compiler works is that within your code, you have a bunch of different macros that you use, and these are a few of the different macros, and the meta object compiler parses that code, and it generates plain C++ from that code. And just give you a little example showing you what that kind of code looks like. So here is an example. So you run the QMake, and that generates these MOC files here. And so these MOC files are the auto-generated C++ code. And so this is how you implement things like properties and signals and slots. The nice thing about Qt is that even though the code base that you work with might not be pure C++, once you run QMake and execute the meta object compiler, the end result is pure C++. So there's nothing fancy about the end object files or anything. It's just pure C++. And so everything just compiles down to normal machine code. This is one of the most powerful functionalities that Qt provides. They call it signals and slots. It's basically an implementation of the observer pattern. And so you have objects that register to different objects, and you register to their signals. And then when that object emits a signal, it calls back one of the slots. Here's a little example. So for instance, you have this class in Qt called QLineEdit, which is basically just a text entry widget. You just can enter any kind of text. And then you have this label, which is just a text label. And the signals and slot functionality works by saying, I want to connect the line edit signal, and so the signal, which would be text changed, and I want to connect it to the label slot. And so anytime I change the text in a queue string, the slots, the text in the label automatically gets updated. So underneath, what this compiles down to is basically just function calls. So there's nothing too fancy going on here. It's text changed. The text changed here is just a function inside of the QLineEdit class. And then the set text slot here is also just another function in the QLabel class. These signal and slot macros are what the meta object compiler works on to produce that code.
Is this necessarily one-to-one, or can you do one-to-many?
You can do one-to-many, so it's really flexible. It doesn't. There's no restrictions on it. Yeah, so you could have the line edit connected to 50 different labels. So anytime you change the line edit text, it automatically updates the text for 50 different labels. By default, these things are all immediate. So Qt has different connection types. So you can have a direct connection where anytime the text changes, it immediately calls the slot. There's no it doesn't get put into the event loop or anything. And then they also support queued connections, which when you change something, when a signal is emitted, it actually adds it to the event loop. And so the slot won't get called until the event loop, until it gets passed back to the event loop and it handles that event. So there's different ways you can actually use the connections.
It's been a long time since I've done any C++,
Yep.
But so in this line here, QString is a class.
Yes. Oh, yes.
It's a variable that's actually being passed.
Yeah. So the only thing you need to pass to the arguments is just the type. Okay. And so this is saying that the text change class has a QString that emits. And so when you change a text, that function that now you're emitting the text that got changed. And then in the function, the slot function, it's just saying it accepts a text. It accepts a QString. And so you emit the QString, and then this function accepts the QString.
How would that work if you had a more complex type?
So if you have your own internal types,
yeah.
the one kind of negative is that you just need to declare your own. There's a macro to declare your own meta type. Okay. And so it's just a single macro call around your class, and you just use that, and then you can use it in signals and slots again. Yeah.
Is there namespacing? Say I have multiple windows.
Yes.
I was trying to think of how this would work with multiple windows.
So Qt themselves, they don't actually use namespaces that much, just because they prepend all of their classes with Q, and so that's sort of how they do it. But if you internally, you can use namespaces as much as you want. All you need to do is just include, if you want to, you would just include the namespace as part of the function.
Okay. The second question is debugging.
Yeah.
How would you? Can you watch or debug or have a debugger say, okay, the signal just went off to this slot?
Yes, I believe, so I haven't looked into this too much, but I believe they do support more debugging for signals and slots. But since this all compiles down to just C++, you could even put a breakpoint here and just step through from this point, and you can see the function calls from the signal to the slot call.
Okay.
It's really powerful. I can show you a brief example, a little bit more hands-on. So for instance, we have this little example here. So this is the label. I don't know if actually, let me show you what this example. So for example, in this little button here, this export button, I've connected the clicked signal, which is just the built-in signal for this Q push button class they provide. So when you click on it, it calls a function, which is just, for my code, it's just called show export dialog. So once you click on it, that function for the export dialog gets called, and this export dialog pops up.
So that's like a pub sub pattern, like you.
Yep.
Click on there, you publish it.
Yep.
And then that one was listening for that.
Yes, exactly. It leads to really nice modular code because you can have your class emit all kinds of different signals, and it doesn't need to be aware of who's using those signals or what. And then you can have all these other classes having different slots, and it makes connecting different widgets in different classes really easy.
Can you set that up dynamically? I mean, it seems like if it's part of the compiler, then you can't, right? You can't like have an if something 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 connect this signal to this.
You can actually, yeah. So you can do if statements and connect. It's just doesn't matter how you use it. You can actually even call slot functions dynamically also. There's Qt provides, so because of the whole meta object compiler, Qt provides a lot of introspection. And so you can also call slots dynamically and stuff and do connections and disconnections all dynamically. Yep. Using the meta object compiler, Qt also provides a whole properties framework. And so you can sort of just think of it as for a class, say I want to have a highlight property. And so you would just use this macro at the top of your class definition. This is basically just saying the highlight property is a Boolean. The read function is this, is highlighted. The write function is set highlighted. And the notify, which is just saying this is the signal that gets emitted, is highlight changed. Unfortunately, the user still needs to actually define the is highlighted function, the set highlighted function, and the highlight change function. But Qt will complain. So for instance, if you didn't actually implement those and you try to compile this, it won't work because it'll say you haven't defined is highlighted function or the set highlighted function. What the property system allows you to do to dynamically set these properties at runtime. So for instance, if I had this widget, I could call the set property highlight and set it to true. The really nice thing is that this is also sort of integrated into the UI also, so you can use CSS style sheets, which I'll talk a little bit later, but you can use CSS style and have a highlighted property so that when this property gets set, you can change how it looks, or you can, when it goes false, you can also change how it looks. The property framework is also used in the whole animations framework. And so for instance, I could set a timer that changes the highlight property every second and just switches on and off. And the animation framework will automatically handle you can have it change how the property looks over time. So the way you can define Qt interfaces, they provide a number of different ways to actually achieve this. You can do it with pure C++. You don't have to use any of the other fancy functionality. So with pure C++, they just have this sort of layout architecture. It's really straightforward. So for instance, you create the widget. And so a widget in Qt is just the base class for any kind of GUI thing. Then you would create a layout. So for instance, this is a horizontal box layout. So it just lays widgets out in a horizontal manner. You create the widgets, and then you add them to the layout. And this automatically handles how the widgets are laid out and how their margins and all that good stuff. They also provide this whole Qt Quick module. And so the Qt Quick module it's actually like a whole separate module, which is actually kind of neat. It has a JSON-like syntax, and it also allows you to do JavaScript expressions. So for instance, this is some QML code, and this is just defining a rectangle inside of your widget. It gives it a width, a color, a height, and it also defines what the text within the rectangle looks like. This basically allows you to rapidly prototype user interfaces. And on the back end, you can also access the Qt Quick widgets from C++. So your back end, which you're doing all the heavy processing, can still be pure C++. So it's super fast. And then the front end can be done with this Qt Quick QML stuff, which is nice because a lot of, I guess, web interface or web people are a lot more familiar with this kind of stuff. Just want to show you an example of how this stuff can be used. So for instance, this is one of the QML applications. And so this kind of interface can be built with just QML. It's still fast, and the code is really straightforward. It's just really declarative, and you know exactly what it's doing. Another way to create interfaces is Qt provides us another application called the User Interface Compiler. It basically takes these UI files and generates C++ code from them. So for instance, on the left here, you have XML code. And once it runs to the UIC, it generates pure C++ code. I can show you an example. So Qt Creator actually has this thing called Qt Designer built in. And so it allows you to build GUIs through a GUI interface. And so, for instance, I can just drag and drop different widgets. And what this is doing is it's just modifying a UI file. And so this is the UI file, and it's just a bunch of XML. So the UIC runs on this, and it generates C++ code.
Once we generate the C++ code, we take it from there and just modify
Yep.
it.
So the C++ code that gets generated, it's really simple to use. So you just have this. This is sort of the boilerplate kind of code to use it. You define this UI object, and then this UI main window object is basically encapsulates the auto-generated interface code. And so from here is where you can access like the central widget, and you can modify all the widgets from code at this point. For styling your application, Qt supports this concept called style sheets, which is basically just the CSS subset. And so on all of your different widgets, you can set the style sheet, and they have really good documentation explaining all the different key value pairs that are supported for each different widget. So for instance, in this example for the button, I'm setting the style sheet. I'm just telling the button to be red and the background color be white. It's really simple. And what this allows you to do is it allows you to easily define how your application looks from external config files. So you can allow users to kind of create their own feeling to their applications. It's just a bunch of text. They also support a model view architecture, which I'm sure a lot of you are familiar with. The only difference in Qt is that instead of having a controller, they have this other concept called a delegate. And the delegate basically provides how you can interact with the underlying model, and it also dictates exactly how each model data item is displayed. Here's an example showing you kind of how the model view architecture can work. So underneath this is the model, which defines the data. So this is basically the data. And then you have different views onto the same data. So here you have a table type view on top of the data. And then on the right, you have a pie view on top of the model. All of this underneath all uses signals and slots. So for instance, while I'm interacting with this, there's something called the selection model, which handles how selections are handled. And so basically, every time I change this, the selection model is emitting a signal saying, okay, what the user is currently selected changed. And then all the views can easily handle that to change how they represent themselves. It's really nicely designed. So if you want to get away from sort of the layout type GUI, they also have this whole graphics view framework. And this is more, I can show you a nice example. This is a bit more freeform, and it allows you to basically create all kinds of widgets and place them in any way you want on top of a graphic scene, which is what they call their base widget. So instead of laying stuff out in sort of a layout form, you can lay out stuff any way you want. So this is an example. So all these little chips here are being shown on top of a scene, and each of these individual chips are their own graphics item. And so this allows users can easily implement their own graphics items, and so you can use this to build games, any kind of type of GUI stuff you want. Qt also sort of provides their own memory management style. It's a bit different than how, if you were to write pure C++, it's a little bit different than that. They have a parent-child memory management style. So basically what this means is that every widget you create will have some kind of parent. And so whenever the parent gets destructed, it automatically goes through and deletes all of its children. This is really nice because it actually takes away a lot of the worry of having to manage any kind of memory. Everything really just works. I've never really had many memory problems, which is always a big negative that people freak out about C++ and stuff. In this little example, you have the main widget object, and then you create another little widget, and you pass it the parent in the constructor. And then when the main window is destroyed, the child widget here is automatically destroyed. They also provide a bunch of their own kind of smart pointers. So I believe one of the reasons why Qt implemented their own shared pointer, which is similar to like Boost shared pointers and also the new standard C++ shared pointers. The reason why they implemented their own was because Qt, they first was created, I think, back in the 90s. And this is when Boost and also a lot of the shared pointer stuff wasn't as well defined. And so Qt wanted to have their own implementation that's well supported on all the different OSs they want to have. And so they basically implemented their own, but this is just a reference counter type pointer. Another really nice feature is they have this shared pointer, or this smart pointer called QPointer. What this does is that it automatically manages setting your pointers back to 0. And so you don't have to manually set stuff to 0. Here's a little example. So for instance, I create the Q line edit, and I just wrap it in a Q pointer. And then so if I were to delete the line edit, now LE automatically points back to 0 instead of pointing to a dangling address.
So it's not null, it's not...
It's 0. It gets set back to 0. Well, null in C++ is the same as 0. What this allows you to do is you can pass different widgets around all different like throughout your whole application, and you don't have to handle those small details where, like, if I delete this object, I now have to go figure out where I have to set this to 0 now.
So C++ like a question, I guess.
Yeah.
When you in that line to delete LE.
Yep.
You can access the LE the variable after that.
Yes. Yes. So at this point, LE will just be pointing to 0. Because, I mean, so Q pointer, you can think of it, the way it works is it's just the same as a pointer. So it'd be the same if I just had a Q line edit. And so you're just declaring a variable. And in C++, you can set a variable to anything, which is why some people get a little bit afraid. But these kind of things make using and managing memory a lot easier. So some of the other features which are really nice. They also provide all kinds of threading support and concurrency support. They have this Q thread class, which helps to manage a lot of the headaches that threads can introduce. So in this little example, might be a little bit confusing, but the basic idea is you create this Q thread object. The thread object is what actually maintains and manages the thread itself. Then you create a little worker object, and so the worker object at this point is not thread aware at all. It's just a plain old class with that just has functions and whatnot. Then you move the worker thread into the actual thread, and then using the signals and slots functionality, that's how you can communicate between the worker object and the thread itself. So for instance, when I start the thread down here, this signal here for the thread, this started signal will get emitted. And then in the worker object, there's a slot called process. And so once you start the thread, the worker will automatically start doing its work in its own function. And all of that is getting executed in a separate thread. these other functions connections here are sort of just boilerplate code that you need to help clean up your threads once they're finished. But this makes working with threads really nice. The other really nice thing about signals and slots with threads is that you can pass objects and you can pass objects between threads without having to worry about concurrency issues. And so depending on how you do it, there's different ways, but if you use signals and slots, you don't have to worry about mutexes at all. So for instance, if I want to pass a queue list of strings, I can connect a signal in my worker thread that works on a list of queue strings, and then once it's done, it just emits it back out as a signal, and then in my main thread, it catches that and it handles it. And the way it works is that underneath it creates sort of copies. So it adds some overhead, but in reality, I think the trade-off is really beneficial because at least for C++, a lot of times copying is extremely fast. You know, it's just moving a stack pointer and stuff. They also do have all of their own queue mutexes and a bunch of different sort of concurrency classes that also makes managing those kind of issues a lot easier. They have things like thread pools, and so you can sort of create this thread pool, and then whenever you need work, you just go ask your thread pool, give me a thread, and it manages all the different threads for you. They also have this whole Qt concurrent framework, which is if you're interested in doing sort of like map reduce type functionality, then the Qt concurrent framework handles kicking off different. If you have a multi-process system, it kicks off multiple processes, or it kicks off multiple threads, and it does that all underneath in the background. And just sort of getting back to the whole cross-platform aspect, this is really nice because Qt abstracts all of this from the different OSs. And so you have a single code base for all of the different platforms, since all the different OSs kind of implement their own threading implementations. It has really nice built-in plugin support. And so things like Qt Creator themselves is it's all built on plugins. So for instance, all of the different functionality built into Qt Creator is all achieved through a bunch of plugins. Within the code itself, Qt makes this really simple. So you would just basically define an interface. You wrap that interface in this macro. And then within your application, you just use this class to load the different plugins, the different plugin implementations, and then you just cast it to the different object types. It's really straightforward, and it makes it really easy for your application to support plugins. It also provides really robust JSON and XML parsing, which is nice. JSON didn't always used to be there, but in the newer versions, it's there now. And the XML parsing is really, really robust. It also supports a bunch of graphics type stuff, and it makes it really easy to use. So like I've been saying, so the base class for all widgets is called QWidget. And so for instance, if you want to bring OpenGL and use OpenGL for the drawing functionality, instead of having to change your whole code base, all you got to do is change the base class from QWidget to QGLWidget. And underneath it handles everything for you. All the drawing is now done using OpenGL. It also provides a whole 3D graphics framework, which is pretty nice. I haven't personally used it. Doing network type stuff is also abstracted, and they provide their own network module. Here is a really simple example of how to use a TCP socket. So I just create the QTCP socket. You use the signals and slot mechanisms to connect to some of the socket's different signals. So for instance, this ready read signal is emitted when the socket has received data. You connect it to a slot, and this would be like, for instance, in your class somewhere. And so anytime the socket gets data, it just calls this function in your class, and you can handle and read out the data from the socket. For this connected signal is emitted once the socket is actually connected to some kind of server. And then this slot here gets called once it's connected. And then the counterpart, which is disconnected, your code gets the handle disconnected function will get called. And it also provides a really powerful database API. It also abstracts all that away from the user, and so they have their own database interface. And then underneath, you can sort of add in different Qt database plugins / modules to support the different database formats. Some of the big ones they support is like SQLite, MySQL, and Oracle database. And they also provide a really nice testing framework. And so you can do all kinds of GUI testing, you can do benchmarking, and it's self-contained, so you don't need any other external third-party stuff. It's just all built into Qt. So given all those nice positives of what Qt gives you, there has to be some trade-offs, right? And there are a few, some more so than others. So this is one of the issues that was already brought up, sort of. So depending on how your code base is sort of architected and whether or not how often you're interfacing with, say, third-party libraries, a lot of times you'll have to deal with converting standard objects, standard C++ objects into the Qt counterparts, just because internally Qt uses all of their own classes. And so, for instance, you have this QString from standard string function that converts a standard string into the QString. Depending on how you sort of design things, this may or may not be as big of an issue. Some people I know like keeping all of their core domain logic in pure C++, only using the standard library. And then all of the GUI stuff, they sort of have the Qt layer on top. You can also, of course, go pure Qt. So everything in your code base uses Qt stuff, which from my perspective works great. It does provide a slightly different programming style than what maybe normal standard C++ programmers are used to. It almost has more of a Java style format, and it uses generics a lot less. So for instance, in C++, a lot of the actual container classes, a lot of their classes are really bare bones. And the reason why is because they have the whole standard template library, and you pass these different classes to the standard template library functions to kind of achieve what you need. Qt sort of has a different approach where each of the classes themselves sort of has all of those functions built into the class. And so they're function calls on the class instead of separate function calls where you pass the object to those functions. In my opinion, it actually leads to a lot more readable, user-friendly code, but that's, of course, always up to debate. The meta-object compiler can also be seen as a negative. It adds another build step, and some people complain that because you have this meta-object compiler, your actual code base isn't pure C++. So this is always up to debate, but once you run the meta-object compiler, the end code is still, it does compile down to actual C++. So from my experience, this hasn't been a problem. You know, it's really seamless. This doesn't, you don't really notice this stuff going on in the background. This is kind of a big one, but it's also dependent on how much you actually use C++ templates. So anytime you subclass QObject, which is like the base object of all Qt classes, you can't use C++ templates with it. There are ways around this where you can basically write your own class using templates, and then you just use that class within your QObject class. So there's ways around it, and I haven't really run into this just because templates are terrible to look at, and I try to not use templates as much as possible. And this is something that Andre also brought up. So all this functionality also does add some overhead. For example, the signals and slots functionality, once it compiles down to pure C++, I think they said it adds about 8 function calls in between. So there's definitely some overhead, but in today's modern computers, you know, 8 function calls is like nothing. So from our experience, it's not any problem. And the benefits you get out of it are really, really nice. And it also, depending on what you want to use Qt for, it can have sort of restrictive open source licenses. For our own internal in-house use, we haven't had any problems with this just because we're not distributing our software or not trying to sell it to anyone really. It's just used for our own group. We haven't found problems, but I know that if you start trying to use Qt and selling it as a full application, then sometimes you need to actually purchase it or use certain licenses, which you might not want to. So that's pretty much it. That's a basic overview of Qt. I didn't cover on a lot of stuff because it actually provides a ton of other stuff on top of that, but that was a lot of the core features that I think provides immediate benefits to people. It's cross-platform, open source. It's super fast because it's C++ and it compiles down to machine code. So this is sort of like the counterpart nowadays to like web programming. So now that everyone's trying to use like Electron for things, which you're basically running a whole entire Chromium engine for a single application, which is kind of crazy. And it also generates these huge applications. So instead of having that huge overhead, you now have these machine code applications, which is really nice.
That's great. I have 2 questions.
Yeah.
Trying to make sure I don't forget them.
Yeah.
I'll ask both of them. You can answer them anyway.
Yeah.
All right. So I haven't touched C++ in probably 16, 15 years. A long time. But I have a project that's coming up that's probably going to be doing some VR stuff in C++. What's the best way to get reacclimated with C++? And then the other question I have is more related to Qt.
Yeah.
So how does like migrating from version to version, is that a problem? Do they tend to be backwards compatible?
Okay, so I'll talk about the first one. So depending on how much you want to program to the Qt style, I would almost recommend that if you're interested in using Qt, go straight to the Qt documentation and build from there, because the way that a lot of the Qt style of things eliminates a lot of the kind of worries and problems that you have with pure C++. You don't have to worry about all those nasty memory management issues. A lot of those weird corner cases sort of disappear. Because templates are useless, you don't have to worry about all the template nonsense. And so I would recommend sort of looking at the Qt documentation, working from there. And if you notice any kind of holes in your C++ knowledge, then you can go and search for those kind of things when you need it. But the documentation for Qt is so robust. There's so many examples that like it's really, really easy to get started. I can show you. So this, in the Qt creator itself, built into it when you download it, it just has all of these examples built in.
Oh wait, I think I missed that. So the IDE or the editor you're in
Yes.
is specific to for Qt?
Yes, so this is called Qt Creator, and this is provided by Qt. This really just nicely integrates with all kinds of Qt functionality.
So this is also the repo access. That was going to be my question. What's the equivalent CPAN or?
So like version control type stuff, or?
No.
Package manager.
You have all these plugins.
Yes. So Qt themselves doesn't have any kind of package manager type stuff. That's all done sort of third party. And so things like KDE framework, which is a bunch of like third party widgets and stuff, that's one type of sort of package management. But there's no built-in package management for all kinds of user-built widgets and stuff.
But you said this is all the plugins.
So these are examples.
Okay.
So when you download Qt, and inside of Qt Creator is all these different examples for basically anything you want to do with Qt Creator or Qt. And so if you're interested in sort of doing any specific type thing, you can just double click on this. It has a tutorial on how to do it, and it automatically loads up the code base. So now this is the whole code base for that example. It also has a bunch of more in-depth tutorials, which really steps you through every single step in the process. This is like a full-fledged IDE. It's really powerful. You don't even necessarily need to use it with Qt. You can use it with pure C++ also, and you can also use it with like really nicely with C. It has a lot of the modern functionality that you kind of expect from IDEs now. So it has this, they call it their locator. And so the locator is sort of the global location where you can quickly navigate to all kinds of different things. I'm sure some of you are familiar with like Sublime Text has that kind of functionality. PyCharm also, and all the IntelliJ IDEs have that kind of functionality. So for instance, if I want to jump to like a function within the file, I can just quickly jump to main. If I want to jump to like a class within my whole entire project, I can quickly jump to that. It's really nice. Of course, it has all the normal code completion and all that stuff. And it has a built-in debugger for all debugging purposes. This hooks into GDB and CLang's debugger.
Yes. But when it comes down to debugging and fixing and getting the features that you want, it's more, sounds like it's in the C++ world.
So it's really all dependent on the user. Qt provides a bunch of different ways to do stuff. At least for our code base and how we do stuff, we do everything in pure C++. So all GUI programming we do in C++. We don't use any of the Qt quick functionality or any of the UI functionality. Okay. But whether or not you decide to use that stuff is really up to the user.
All right, I think your screen popped out.
Is that working again?
Yeah.
Click join at the bottom. Sure.
I should be unmuted.
Yeah. Yeah, you're good.
Yeah, so through the whole introspection functionality that Qt provides, it allows you to like really test a lot of GUI functionality really easily. So I can just show you some examples on their stuff. So for instance, you can basically catch signals. You can simulate clicking. So you have things like Q signal spy, which you can basically attach to all the different signals in your widgets. And so you can capture that and do testing on that. You also have, oh, it's not giving me the classes. Oh, so here you go. So you can also simulate test clicks and stuff using like functions like this, so key click. And so basically that just inserts events into the main Q application to simulate different clicking on the screen. And so basically any kind of GUI type testing you want to do, they provide that ability.
How does like the distribution model, like if you're, let's say you're your own center and you're doing something and you want like something to the dev group, or you want to distribute it to everyone in the dev group.
Yeah.
How's the how would I distribute it, and would everyone need EP to install it, or
like the application itself?
Yeah.
So the way you distribute applications depends a bit on the OS. So for instance, all of our development we mainly do for Mac OS, and so Qt provides this application called Mac Deploy Qt, and so you just run that on your generated application, and that basically bundles the whole application into a DMG. And then so you can just pass around the DMG and install it on users just like any other Mac application. For Windows, you can, they don't have any built-in for like installer type stuff, but there's plenty of Windows installer type applications that you can use to package that up and generate an EXE. We've actually done that for some of our other applications that we use on Windows. And then for things like Linux, you kind of just have to, there's some things, but since it varies so much depending on the distribution, those are kind of left up to the specific distribution for actually generating the packages.
Like same would apply for updating.
So for like updating the application, that's up to the application itself. There's no built-in updating. So you can either just notify users there's a new update and they have to manually update it, or you can sort of build your own updating architecture. And I'm sure there's some third-party implementations that provide stuff like that, but nothing built in. Getting back to the one other question you had with the different versions.
Yeah.
So at least now Qt is really stable. So going from Qt3 to Qt4, that was when, so the major versions is where they sort of break backwards compatibility. So Qt3 to Qt4 was one of the biggest changes. They kind of revamped a ton of their API. They broke a ton of stuff, but that really improved a lot of things. It made the API a lot simpler. It made things a lot more consistent. Going from Qt4 to Qt5, there wasn't actually that many changes. So originally our code base has been mainly Qt4, but we've tested compiling it to Qt5, and for the most part, it just works. And then the minor versions, I think they're currently on 5.9.2. So between minor versions, they generally don't break backwards compatibility at all. It's more just adding new features and bug fixes and stuff.
And how rapidly are those versions? Like, how long was it between 3 and 4 and 5?
So I don't know their release cycle, but it's actually pretty frequent. So I think when I started 3 years ago, Qt5 was brand new. And that started at, I think, Qt 5.1. And so now they're already up to Qt 5.9 through just 3 years. And they're actually getting ready. I think Qt 6 is like on the horizon, and they're getting ready to release that soon. A lot of what Qt is sort of focusing on nowadays is that they're putting a lot of effort into sort of the mobile section. And so a lot of the stuff is sort of mobile oriented. They also do a lot of sort of web type stuff now. And so they have a whole web engine that you can also execute.
So you can create an app for like an iPhone using.
Yep.
Really?
Yep.
I thought that was like the whole proprietary, like thou shalt use the Mac compiler.
GCC?
So I'm not actually sure if it works for iPhones, but I know Android they support really well.
Right.
I don't actually have any experience with iPhones.
I think you can run C++ on the iPhone.
Yeah.
You just have to have a Mac to author it, like to do the signing thing.
Okay,
Yeah.
that's what it
Yeah.
is.
The developer.
There's like you have to, like the same thing with C#. You can run C#. You can write C# for the iPhone, but you have to have a Mac in your pipeline to do some signing bit of it. So some I have to make sure they get their money.
And it says you can do iOS with Qt.
That's about it.
One,
Thank you. Okay.
one recommendation I would say, black on red really hurts. At least trying to read it on that one, that's.
It was pretty clear on the side. It's just-
Yeah, probably getting a little worn out.
Thank
Well,
you.
thank you.
Thank
Yeah, appreciate it. One final quick note: if anyone wants to, I think we're going to try to like divide the task for the dev group. If we can get like dedicated people for different things, so that no one person has to kind of do a lot. If you want to do that, just stick around afterwards and let's have a quick conversation. Just tell me what you want to do. We'll do that. The thing we really, really need help with, it's the hardest and it's kind of hard to see most times. It's just like that takes a lot of work behind the scenes. But it's the most useful thing. Without a speaker, we really don't have. A dev group, the pizza wouldn't matter, room wouldn't matter, notes wouldn't matter. None of those things would matter without a speaker.
Should go back to the days when it was just you presenting every single time.
This is about the little hand again.
You know, put it up again.
That's one of the reasons why I wanted to start doing this, because my time is starting to be even more divided. So it's like getting harder and harder to keep up. So if we can get, I think our group is big enough now where it's like if everyone takes a little piece, it won't be any rollover anymore. And we have a backlog of items. We have a number of people that have already presented to, so they have experience presenting. So we can make it work. But I'm just worried that because I think some of these, I don't want when I can't make it or not be here that we just don't have that work false.
Yeah.
That would be tragic, I think. Cool. Thank you. Notes will be out. Video looks pretty good so far, so